So this kind of base concept of virtualization has then introduced us into the cloud. So this cloud buzzword that's out there has a lot of different meanings, and depending on where you are in the stack, could mean any of these things. Yeah, is there a question?
We have a question.
Yeah.
Yeah, go ahead.
Yeah, in your previous slide, on a physical machine, you use the local hard drive for the Hadoop distributed file system, right? So when you have a virtual machine, are you mounting the local, some partition of the local hard drive to have your Hadoop file system on them?
So if you look at, and we'll get into a little bit more with some of the clouds, but there's capabilities out there in what's called elastic block storage, where you can actually mount this block storage that then makes it persistent, right? So if you're not worried about persistent storage and you just want to install on the ephemeral storage, you can install locally on that instance storage that's available on those devices. But if you actually want to have persistent data, typically the best practice is to install that on block storage that you attach to a running instance. Does that answer your question?
Thanks.
So, and we touched on this a little bit, so I'll kind of go through this, but the cloud was kind of introduced in this model, and where it's attractive both for academics and for industry is it provides some nice properties for us to be able to look at challenging large problems. So we've talked a little bit about virtualization. Everyone's fully aware of the internet, right? And both of those kind of brought together brings us to this concept of the quote-unquote cloud, right? This buzzword. And so some of these properties that become interesting for the cloud are scalability, this ability now to go into a data center, multiple data centers, right? And we know this for a fact from clouds like Amazon, right? They've got data centers in Northern Virginia, they've got data centers in Oregon and Northern California, they've got in Europe, South America, the Far East. So all of a sudden now I've got data centers and I've got capacity that maybe I'm not used to, right? And I guess one of the benefits that we have here in America is we have these nice campus clusters, and we have this campus grid environment that's been set up to provide us with a nice scale. But that's not necessarily the case in industry, right? In industry, typically people aren't collaborating with other industry institutions. So for example, you can pick something like the pharmaceutical industry, and typically a company's not competing or collaborating with its competitors to say, hey, go ahead and use my cluster, you know, and that's obviously a lot bigger sharing environment that we have here in academics, right? So all of a sudden, places in the industry will start using the cloud because they don't have the scale internally that they can get from a place like an Amazon data center, right? So, and I'll touch on that a little bit more here in a couple minutes. So the other thing with this is elasticity and utility computing. Utility computing is a really interesting one in this play, is because when you get into finances of actually purchasing hardware versus running it on hardware that you're renting by the hour, those are different types of expenses. And that may not mean much to you all, but when you start to work with finance departments on actually, do I want to do a capital expenditure or do I want to rent something by the hour, those dollars are different. And so this concept of utility computing allows me to get literally thousands of cores that I could pay for with a credit card, right? That's a totally different model than all of a sudden I'm going to build a supercomputer in my data center for millions of dollars, right? So I'll use somebody else's infrastructure, I'll use their hardware, and I'll build a cluster on top of it, and I'll pay the $1,000 per hour to use it, right? Now I may lose some performance benefits from that, but the fact is I didn't have to go through all the networking, all the drive replacements, all of the details that go in behind the scenes that people aren't maybe fully aware of that happen in the data centers that we see to be able to use these computing environments that are available to us. So from this kind of high level of virtualization in the internet and this cloud topic, we have 3 levels of service that have kind of been defined out there for the cloud. And I'll give some examples here, right? So this top level one that people kind of call is this like software as a service. So people out there interacting with your Gmails, your other web-based emails and that, right? You've got these properties of scalability, elasticity, but you're using kind of a software interface into their cloud, right? We don't know the details of the computers that are behind the scene when you go to check into your Gmail account. I just assume I've got elasticity, I've got scalability, and in some aspects, actually, it's free for me. I'm not paying for a per hour unless I go over whatever they're up to now, 5 gigs. I don't remember what the size of Gmail is, what the maximum size is now. But, right, you've got this model of I'm not paying for the hardware underneath that. I'm I'm just paying for the utility of using that service. The next one under that is called platform as a service. And this platform as a service says, I'm going to kind of give you a framework that you can kind of put your software into, right? So if you kind of program to our standards, we'll let you go into our platform. And so Google App Engine is an example of that. I can actually create a Django app, or I can create another web-based app and plug into their application engine to do my work. The lowest level of this is called infrastructure as a service. And the reason why it's called infrastructure as a service is because you literally have the nuts and bolts available to you to create a virtual machine. How big do you want it? Create block storage. How much storage space do you want? Attaching those. What device do you want that to be on? And what should be your mount point? All these low-level details for, in this case, building out a virtual cluster for Hadoop, right? So these are very technical details, and maybe I need to know the technical details. Maybe I can go high enough up into the stack that says, hey, I'm just a web developer. All I want to do is develop an application into your platform. And so maybe Google App Engines is an interesting one that I want to play in this space. So you have these variety of levels that you're dealing with, and there's complexity as you work your way down that stack, right? You have to know the details. And so these are why sometimes people having more of a computer science background or more of systems, may be more interested in infrastructure than saying, look, literally, I just want to use the offering that you're providing at Salesforce.com to deal with my sales staff and take advantage of the cloud that you have behind that.